Hello and welcome to today's SEI webcast, our software development open forum, Ask Hasan Anything. My name is Shane McGraw, Outreach Team Lead here at the Software Engineering Institute, and I'd like to thank you for attending. We want to make our Q&A today as interactive as possible, so you can submit your questions in the YouTube chat area now. If you're on LinkedIn or Twitter, you can use the hashtag AskHasanSEI. Once again, that's AskHasanSEI, and we will get to as many as we can. As I mentioned, our subject matter expert today is Mr. Hasan Yasar, and Hasan is the technical director of the Continuous Deployment Capability Group here at the SEI, where he leads an engineering group developing prototype solutions with DevSecOps. He specializes in secure software solutions, design and deployment in the cybersecurity domain, including digital investigation, incident management, large-scale malware analysis, and Hasan is also adjunct faculty at Carnegie Mellon University. So that's his formal bio, but Hasan is one of the great resources for our nation, all things DevOps and software development in general. And he has a great passion for this, so I want to welcome Hasan. Good afternoon.
Good afternoon, Shane. Thank you so much for having me. This is one of the passion topics I have been really eager to research and discuss and share the knowledge with the community so we can all get better and building a reliable and quality software at that. Thank you so much, Shane. It's good to have.
Great.
Good to see you as well.
All right, enough for the small talk. You're now on the hot seat, so we're going to start firing off questions to you. We got a number that came in prior to the webcast, and then we will get to some that are coming in live as well. So let's get to question one from Hasan. From Laura asking, SBOM or software bill of materials is a hot topic. From what I know, SBOMs are a way to quickly act and determine the impact of an upstream compromise. Will they detect a build compromise?
Yes, it's a really growing topic right now, Shane, for the SBOM, especially for dependencies or open source, whatever you call about it. I think let's define what the software bill of materials means. It's basically all the software components, that is including open source, including any type of dependency in the application that you're using it, and make them as visible, make them as traceable throughout the life cycle. When we say like a traceable, it's basically we have to know what other components are we are using it, what the versions are we are using it, where we are using it. That's actually two couple of things, like what the version that we have it, and where we are using that libraries in which context, like maybe a server, maybe some of the dev, maybe some of them is a build package, some of them is runtime package. If we know that where it is we are using it, so we can be ready for any type of incident, any type of vulnerabilities it's becoming for specific vulnerability for that libraries. Because if you don't know where it is, if something happens for a specific libraries, if you don't know what we have in our infrastructure or the build process or environment, it's very difficult to find that and patch that because we are racing against the time. And like there's a concept of the 0 day, even though the vulnerabilities exist, like identified older in the community, as an organization, if you don't patch that vulnerability timely, that within the application, it is going to be a 0 day still for us. So we have to be very effective with that. How can we do this effectiveness? It's really a good software delivery environment, such as doing a good DevSecOps end-to-end, will help us identify those vulnerabilities, identify this type of libraries easily, or we can keep track that libraries throughout the life cycle. We can go and patch that. I know we're going to discuss most likely, I'm guessing it because this is going to continue. I think we're going to see how we can build up SBOM as part of continuous integration. How can we build up the SBOM using a single source of truth as an example? How can we connect the dots so once we go to the further dive into the question, I will come back again and answer that specifically. Overall, using a good practices and end-to-end life cycle with DevOps component will definitely help us to speed up and be aware for any type of vulnerability, any type of the dependent we are using in life cycle.
Great. Question two from Raul. He wanted to know, what are the core operations of DevOps? Can you define a typical DevOps workflow?
Oh, great question again. This is I'm glad that question came at the beginning of this topic because we're going to build up the rest of the talk, most likely going back direction. I'm going to go back to the whiteboard and write something in the whiteboard so we can really discuss more interactively, say what is the common components are. So when I really give what really DevOps means, there is four fundamental principles of DevOps. And one is the collaborations that we do. And the second one is the infrastructure as code. We kind of call it the IAC. And third one is automation. And fourth one is about the monitoring. So this is kind of like more about the common principles that we were talking. I know there are dependencies. So what really means this core component for us? I know people heard about the culture as one of the elements. I kind of give the analogy of building up a DevOps is, think about that you are really driving a car on a highway. Like you just go fast as much as you can in a highway, but you were looking for a good highway, right? If you don't have a great highway, no matter what type of car that you have, no matter what type of brand that you have, you cannot go as fast as you can. So let's think about this analogy in here and take a look at perspective. So we need a highway, we said, right? We need a really good road. In this road, we can drive car fast. So what means in the software world, we would like to really build up the code, we deliver as fast as we can, and end of the day, we can safely arrive our production environment, which is our destination, right? We would like to go into production at our destination. To achieve this road, it's really requiring to build up a great infrastructures. It is important to build up a right infrastructure, which is give us a ability to automate and give us a repeat the same environment over and over and again. It's going to give a high degree of assurances that we don't have any intruders that go into the road, so kind of block that, which goes back to the SBOM that we discussed. So we can really block anybody goes into the highway, which is kind of build a highway. And how are we going to build up the highway? We have to understand our team, which goes back to the collaborations. Like teams people are going to use this environment. People as us, like a users, right? We would like to use this highway. We would like to use the application that we are building. We have to really collaborate with the team to build this infrastructure. At the same time, we can use effectively with this infrastructure, requiring the stakeholders. So collaboration is all about the stakeholders, and the stakeholders has a visibility or has to say something in the software lifecycle that we are looking for. So let's look at the other two elements with automation and the monitoring perspective. Let's build up the highway. Teams are agreed on it, and we have drivers, we have users, we have developers, we have architect. Everybody is kind of a part of that, our discussion, our team, even though we have cops on the road, which is the security people usually, right? Cops are looking for anybody goes high speed or anything else, we can trap it. Same analogy in the software world, we have cops. Cops actually helping us to go as safely in our destination. So with this concept, now we would like to automate that. What we are automating is we don't want to have, if you're going to fast in a highway, like, you have a great car, you're going to maybe, 75 miles per hour, whatever the speed limit is, because we don't want to go above the speed limit, of course. So within that condition, we would like to go as fast as we can. How can we go as fast as we can means we had to automate that some of the steps. What automations are, let's say we go through the payment system, like, we have to go through the ticketing system, probably in your highway, or you may have the checkpoints in the highway. Same thing for the software world is true. We would like to go fast by building the components, by compiling, by testing, by delivering, by deploying. It's requiring a automation. So we build up IAC. Let's go a little bit layer. So we have the infrastructure as the first layer, we build it. So now we put the code and application on top of here. To make sure that it is going fast, we have to use automation in our deployments. So like we can test it, we can build it. So we have this combination, we automate the build and deployment. Now, next one is, how are we doing well? Like, how are we targeting a time goes into our production environment that we have? Production environment, or we may have other testing, or we have a staging environment that we do. So go in this things like how we are doing well in terms of how we're driving. We can improve our practices, we can improve our knowledge, we can improve and some performance of the system is requiring a monitoring. So we have to really monitor our progress, how we are doing well through the life cycle, we can get better. And also monitoring is also loaded term. We would like to monitor how application is behaving well. And also we can collect the feedback. So feedback is from stakeholders, from our users. We can collect the feedback. We can monitor those, get into our team that we were talking about. Let's go a little bit up. So teams, it's going to be our collaborations. People would like to share that. So like fundamentally, DevOps is building up a good way of building the software that we have to speed up. When we go fast, we have to use automation practices to go fast because otherwise we cannot go fast. But to automate some of the component that we are building, there's another dimension in the DevOps, which is more architectural element. Like if you cannot really architect your system well, you cannot automate some of the practices. If you don't have, you have a great road, you have a great turnpike, you have a great the component that you build in your pipeline as your road. If you don't have a good car, that you cannot go at higher speed, which is the similar analogy. Like you need a good car, you need a good architect, you need a good component just so you can drive fast. I hope that answered the question, Shane. That was
terrific. The drawing definitely
fundamental
helped.
Topic.
No, that was great. Like I said, the drawing definitely helped as well. So let's keep that going too, Hasan. We're getting great chat interaction. People letting us know where they're from. We got truly a worldwide audience, which is great to see. So I want to work in a chat question here from L. Brandt asking, I don't know where to learn to go from being a developer. From being a programmer to being a developer, Hasan. Any questions or any suggestions how they can go from a programmer to a developer?
So let's take a look at, again, this is more about the workforce related question we are talking about. So for us, like a programmer, it seems very limited to the certain language we are talking about. Let's say in our project, probably we might be using some specific language, maybe using a C++, you're using maybe a Node.js or some other things, kind of like you are programming. But when you talk about the developers, a developer has more content in it, like the developer not write the code, but sometimes we do a good design, Sometimes we will like architect our system to address some potential problem that user may have it. So developers, it is more, I think more about software engineering practices, we say, and that has the good understanding about how can we do a database design, what is relational database I can go, what are the typical algorithms that we can use in our context that we are building. So where we can start, typically it's about the passion. When I give like either the programmer or what the developer you're thinking, you should have a passion. So what really means, like I have been programming almost 25 years. If I did a great code that I'm writing, my mind should be clear. I should have really put myself into the situation. I should put myself in a person's role, in a user role. I can do the better at writing the code. So it's kind of like I describe as the developer. It's basically like writing a poem or drawing a picture as an artist. So your mind should be clear. Your mind should be in the work to really the good job or understanding the needs. Because we are using our head. I mean, whatever we learn, whatever we have understanding for the system we are building, it is requiring to build up our knowledge, build up understanding, build up the domain. We can be like one of the users. We can be like one of the end users. We can be like one of the architect example. So where we can start, again, really you should have a passion. If you're looking for just the writing the code, maybe you can be the good programmer, you can write the code. If you're looking for the good developers, you should have a passion about understanding the context, understanding the system, understanding algorithms and development. And where you can start, again, there are different curriculums, different universities are offering. And like, as far as I know, there's a computer scientist almost everywhere in the US, most of the universities has. And some universities are also teaching software engineering practices as well. And if you're going to be just a coder, there are a lot of open source or there are a lot of learning platforms available. Just teach the code like you can learn C++. Another thing I would like to add here, and I can be a good developer. If I'm going to switch to different language, I can go take a look at what the language means for me, and I can learn that language, then I can still write the code. It's like being a developer, understanding the context, understanding the system, understanding how the memory layout, how the communication, how the interactions are from the system to the other components. will help you to use the different languages. I get different, like I get the analogy of, let's say I'm speaking in English right now, right? The kind of I've made. If I'm going to speak different language, the object is not really changing. Object is the same, like chair is the chair, but the verbiage is changing for a different terminology. The programming, it's going to give you an ability to change the different term. You may have a for loop in C++, you may have while loop in Pascal or other languages. It may be different interpretation, but the context is the same. Context is the same of writing the algorithms and components. So again, going back to the how can we learn? And if you're going to be a developer, you should get trained from the college or the engineering perspective. If you look for a programmer, just to learn the language as well from any open source environment.
Right. Next from Steve asking, how can you assure the security of the software development pipeline? If a pipeline is hacked, the software could be compromised and internal testing may not show that.
Yes, so I know we are paying that a lot of attention right now, which is a lot of the happening through, especially for the solar wind, a couple other examples. I brought that screen so we can discuss more in the pipeline perspective. So it's a great thing. We typically, as the community, we focus on building the good quality, secure application. We often forget how to build it. How to build is the key point, like where we are building, which is a software pipeline. So if you look at this picture, this is the section, and we typically use right here, this is our pipeline, which has left a little bit bigger, which has the continuous integration, continuous delivery, other practices that we have. This is our pipeline. But if we don't secure this pipeline, what that means securing a pipeline? Let's say I'm a developer, I'm right here as a developer, and I'm going to use, right there, I'm a development team. I would like to use some of the libraries and to achieve my code, because typical current developers and as an engineers, we are so much complexity that we have in our environment. Like if I'm going to write a code, I just go to Google it and go to GitHub to get something is available for me. I don't want to reinvent the wheel because we are racing with the time. So with this rationale behind it, I can get the libraries put into my pipeline. That's going to be part of my continuous integration example. So suddenly I'm inserting X library here into my build process, which is how we're getting the open source, which is SBOM component. Second component is how are we going to securing as the configuring of this pipeline? Let's say we have a continuous integration that we have a continuous deployment. In the continuous integration, we might be using some build server, like maybe Jenkins, just to make it more realistic example. In the Jenkins, and I'm giving another one example, which happened recently in November, we're using some static analysis tools that we may have for security perspective. So if you don't configure these two tools properly, now we are opening up a vulnerability for the people who can attack it. So now it looks like we are in the perimeters of a network infrastructure that we are protecting. But if you don't configure each of the tools that is part of your pipeline, it's opening up an attack vector. People can take an advantage of using one of the Jenkins configurations back to you. Even though almost every tool vendor are describing here's the best practices to set up your Jenkins, set up your GitLab, set up your Docker, set up your Kubernetes, it exists already. As a practitioner, we just go and download and grab it by default and then try to install an environment without even thinking, all right, how can I make sure that I have a good secure implementation of this component? How are we going to make sure that Jenkins is able to segregate multiple builds in the build steps build perspective? So we have to step back, think about that, how we are thinking about application security. We had to think about as the pipeline itself, and how can I secure the pipeline? How can I secure means how can I configure it properly? And then how can I be ready for any type of outage in the pipeline? One specific example I can give, which actually happened a couple of years ago, one of the smart, I'm going to say hacker people, they used one of the build agents and then put a data mining vulnerabilities into the build agent as part of the build server, doing data mining through the pipeline. It's a great idea because build is keep running, and then you don't really pay attention how the build is acting. So you're giving a free resources for adversaries and taking advantage of build agent and running a data mining on the build agent, doing some other process as part of it. How it is get there, which is about the lack of configuration, lack of not monitoring libraries. And then we don't have a monitoring that we discussed at the second question, I believe. If we don't have a good monitoring, how are we doing well, how the system is behaving, there is no way we can capture any type of abnormal activities as part of test scenarios. So we have to configure as a summary, we have to configure our pipeline, make sure that we are following best practices. We have to be ready by monitoring any abnormal behavior of the test or the build stages. And third one, we have to have a full traceability. Who is accessing our libraries, our pipeline, what they are changing. Like we should establish the good, secure, commit process into the repositories. We should have a kind of SSH, or we should have a tokenized, we should have a cryptographic deployment. We're gonna make sure that we are accessing the pipeline as an individual. We are following the best practices as well, Shane.
Great examples, Hasan, thank you. Let's go to Matthias. Asking, large-scale agile development often involves huge obstacles to consistently applying security policies across environments with multiple contractors, across government and network boundaries. Any tips on how to deal with this without compromising agility by crippling red tape?
Oh, it's another loaded question. I think we need to spend probably an hour to discuss that. I'm just going to give a quick ideas for that perspective. First of all, let's step back a little bit. So when we look at the scale agile framework or any type of scale agile, so the bottom line, all the work, like we have the multiple systems, we might be using it, we have system 1 and 2 and 3, whatever the system we have. So we have multiple stream is going on. But if you literally go in the level, we are in the developer level right here. So I'm going to pause it here. Let's open up a little bit more. So we got the system that we are building. We have different type of components. But end of the day, agile practices says, you have to really be ready. Like, I don't want to go to 4 manifestos or 12 principles. Overall, we should be ready to accept any changes, what agile mindset says, right? Which is kind of not compromised. But what we should do for the sake of the perspective, when we are writing any stories that developer are going to work on their task, like writing stories, each of the stories should have a security stories as well. So what the security stories mean for us, when I'm writing any stories, like maybe, it can be a higher level, it can be epic, or it can be some like a higher level of the more about the project. But when we look at these epics and stories, we can write a security stories as part of our requirements. So now suddenly we are bringing our security thinking into the level of developer by using the various agile techniques. If you look at the scale agile framework, bottom line, we are using a Scrum as the bottom line work. We do the Scrum work, we do the bottom developer level. Maybe using a Kanban as one of your practices. So these are the typical agile practices. And that goes back to the team level. Teams are using the Scrum, teams are using a Kanban. And team is basically populating and make it more a scale and each of the system level you are working on. So let's drill down in the team level. We start from the security that are part of our code that we are writing. We can bubble up and then bring up that security into the system level we're writing. So there is a relationship between these two. One is, if I know my system's characteristics, if I know my domain, and I should really think about what are the applicable security stories that I have to write in a developer level. There's a disconnect between what the domain requirements are, security perspective. How can I make sure it's going to be applicable to my code I'm writing in a developer level, which is the stories level. So if you have a good bridging connection between the higher level in a domain specific, system specific, go into a level of feature that we are writing, it's going to be better chance to get security as in the scale. But what we do, we're not doing this type of work at the beginning. We always relying as late in the game, like just using the static analysis as an example, it's sometimes too late. Or we just rely on some dynamic analysis. Maybe sometimes we are ignoring, we say, okay, organization, I will continue if something happens, I'm going to go back and take a look again because, I'm just eating up the chance right now. So we're never able to get a more organizational risk, more organizational domain for a security specific. So instead of going kind of like a specific, the not do it, let's make it applicable security for our domain specific so we can scale up. And almost every agile framework, it's basically not against it. It is basically helping, but we have to change our mindset. How can I add security into our agile thinking? How can I add a threat modeling concept into our agile thing? It's just the way of thinking here, Shane. Like how we do the function requirements. I'm just going to go to one more time and just explain a little bit about the software developer perspective that we discussed. If you look at any software that we are building, and there is definitely a quality attributes that we are building. So developer knows what the quality attributes are. One of the quality attributes is security, resiliency, reliability. So we have to really think about all the quality attributes, how we are writing the functionalities. So business says build up that function, but as an engineer, as a developer, we have to also think about what are the quality attributes with respect to security. So it's not nothing is blocked. It's about the way of thinking. So I don't see any methodology is blocking us. It's way of thinking is blocking us. We are not able to prioritize any type of work that we do. It's not in our list. So if it is not in our list as a developer, we just always catching up next one. We don't have enough time technically we do. So.
All right, so we're going to move on and we're going to combine two questions here, Hasan. I think they're somewhat related. Kim had previously asked, what are some differences between continuous integration, continuous delivery, and continuous deployment? And then Kartik added to the chat, what does it take to achieve continuous integration and continuous deployment? So can you tackle those?
Yes, so I prepped it actually. That's a good one because I know it's going to come up with the continuous integration. So we have been doing the integration of maybe years, like even though when I wrote the program probably 30 years ago, I was in integration. But what the continuous integration means, that's a little bit, I'm going to come back to this graph shortly. So we have various team members, like the team A, team B, team C are building the code, and within their environment, eventually we have to merge this code, and then we have to build that. What build means, like we're just getting a code and then creating a binary artifact. So this binary artifacts, it's going to be used in the production or the testing environment, right? So this is kind of like a build process. We have to understand what the build means. Beta is going to get the code and then package it, and depends on the build steps and creating some binary artifacts so we can use for various things. So now in the concept of the DevOps or the modern thinking, we are adding a continuous term here. We are adding a C term. Like this is kind of like an integration level. Now suddenly we are adding a continuous integration. What the continuous integration means, so we're going to get the code. We will get the code from repositories. Remember we mentioned about infrastructure at the beginning. So we will get the code plus other artifacts. Other artifacts is infrastructure code. Other artifacts how we're configuring system. Now build that. Now we are building, so creating artifacts, creating and the testing, and then eventually we're going to do the deployment shortly. So continuous integration will help us to gather any changes from repositories. We get from repositories that kind of get change happen in the repos and developer pushed it. A team pushed something and B team for the person wise or a team. So we can grab the code from repository and package it, and then make sure delivering to the staging, testing, environment. So in the build process, we're not again just getting a code, we are getting other artifacts because the software that we are building right now, there are so much dependencies in the software. That goes back to the SBOM question at the beginning. So we get the code, we get other artifacts, how we are creating a deployment as an example. How are we creating a dependent libraries as another package? And so we get all together. Maybe we're building the code, we're just going to push into production. We didn't know what operating system requirements are behind us. And third one is, this is the first time probably you may be hearing that, write the code, we have the infrastructure, now we're adding a documentation in it. So don't think about that we are creating a Word documents in the context. This is more about specific information about our system. Our system that we are building, maybe some specific user guide that we are creating. Maybe we have some notes that it is relevant to how we are configuring an environment. Maybe some notes that's specific to how we are writing the requirements for the code that we are building. So suddenly build is combination of the code, artifacts, and other documentation, we can build it. Because as a result of the build, we are creating an artifact. So artifacts is a binary, but sometimes binary is not enough to run with the production environment because you need other information for a security perspective, for a maintenance perspective. I saw so many examples and the bad practices in software engineering thinking. We are running the build in the production environment. We're never able to go back and reproduce again because we don't have right build steps, right configuration, right documentation, right infrastructure code pieces in place. So the continuous integration is basically combining all of it. So let's look at the continuous delivery and deployment. Let me get it bigger here. So I'm just going to give a quick example about the just to set the stage SDLC. So we have the requirements that we write it, and we have the design, kind of like architect as well here. And we have a development and we have a testing. So we are in the deploy that goes in the production environment. So typically continuous integration is happening somewhere here as a continuous integration. So we got the code, we are building, and now we make sure that we have the CI. So continuous integration is going to get a build artifacts for us. What is next? So after build artifacts, there are two concepts. One is a continuous delivery. Another one is deployment. It's often a confused term. So both of them intend to really go into the production environment. So deployment, get artifacts and do some testing or requirement testing, including security, and automatically pushed into the production environment. That's kind of deployment goes into the production, which user can see as live as an output as a result of the build. What the continuous delivery is, it is manual to production environment, but it is automated into the staging environment. So as an organization, we need once we build artifacts, we can go to test harnesses. We can initiate the different test harnesses. We can create more test cases, test environment. We can deliver the artifacts into the staging or test harnesses so we can do more testing for the artifact that we build. When we are done, we can manually put this artifacts into the production environment. That's a continuous delivery. And deployment goes automatically. So next question we may think about that, can everybody do continuous deployment? It depends on the business needs. It depends on the system that we are building. Can everybody continuous delivery? Yes, we should do continuous delivery because that's the intent of the building a software fast. We can test more and more and more. When you're ready, you can manually get artifacts if you want to put into your production environment. Okay. So quick summary, continuous integration will help us to build artifacts from code, infrastructure, documentation, all information. We can package it, version it. Then we can test it, the content in the staging environment, make sure everything is working fine, which is delivery. And when we are moving into the production as the users that can see automatically, that's a continuous deployment. So deployment really is specific to the business need. Deployment is specific to organization needs, as an example.
Great answer, Hasan. Thank you for that one. Next, we're hearing about the software factory concept from our government customers and seeing it in RFPs. Can you explain what is a software factory?
Yes, thank you, Shane. That's another kind of old term. And let's make sure that there's the same concept here. There's the drawing. I think I can quickly make sure it's ready so we can reuse again. So the software factory is not a new term. That came about 1971-ish, like when we are building up our softwares, when we are writing a code. So software factory is going to help us, or as a concept, as an umbrella, and we may use the multiple pipelines. Right here, we have a multiple pipelines that we can edit, so we can produce a software, or we can produce a system. So let's open up here, just going to come back shortly. So you may have software factory here. So you may have various software delivered environment. You may call as a DevSecOps environment. Let's make it a little bit shorter so we can make the graphic better. We may have a DevSecOps environment here. We may have another DevSecOps environment here, and then here. Because each of this pipeline that you are building has a specific requirements for the system, maybe the components that you are building. Maybe you are building some of API here. You may have some other complete system probably you're building. So the combination of the multiple pipelines is constructed and building a software factories. So software factory will help us use the same practices. This is important. We're using the same practices, same process. Like process R, we have to check in, check out, we have to connect it, we have to create an issue tracking, we have to create a case, we have to create a commit message. These are the more about practices and process. But however, we may be using a different tools to establish that, because DevSecOps pipeline sometimes depends on technology we are using. Like one example, C++ build process is different than packaging a Java code. You need a different type of build agents to build up the C++ code versus packaging about the Java libraries, differences. So still we are building a software, but because of the component has a different needs, we may have a different pipeline. So software factory consists of multiple pipelines, but enabling using the same practices and same process. As an organization, we can do. One quick example, going back to the first question again, because it's hurting us. It's hurting us specifically. If I don't have a good practice of getting the libraries, it is more organizational policies, more organization practices. As an organization, we should help or guide the developer pull the libraries properly from open source, or manage the artifact catalog in organization. We can use it over and over again in the pipeline, which is a practice. Or if I'm writing any type of stories, it doesn't matter what type of tool you might be using it, think about the security knowledge at the beginning, and then organizational policies, organization practices. So software factory is a combination of multiple pipelines, and letting us use the same process and practices, we can deliver an applications, or we can deliver apps as a result of these combinations. So single DevSecOps pipeline is not. One quick example here before going to the next question, like AWS or Amazon, they have hundreds of pipelines. Hundreds of pipelines. They design the pipeline for a specific needs. Maybe they're creating one of the microservices, they might be creating the pipeline. So technically, like Google or Amazon, there's a typical software factory they are talking, building a software. But say they're using the same practice. If you look at that, Google has a good software engineering practices everybody's following. It is not a wild west, everybody can do different things. No, use the same practices, process and practices, we can deliver that. Actually, a definition of DevOps is also a set of principles and practices that enable Dev and Ops, including other stakeholders. This is a quick definition. It's going to tell us again, set of practices and process, such as continuous integration, such as continuous delivery, such as continuous feedback, IAC. These are the common principles.
John sent in, how well are high schools, colleges, and universities preparing software developers to take advantage of newer technologies and trends, such as the software factory principles you just talked about, model-based software engineering, and low-code/no-code platforms?
Oh, that's a good one. Actually, I'm going to give an example from my son. So he just, this year, he was in the 9th grade, actually 10th grade, and he's doing more about the Python learning. So high schools, it's a good opportunity to let the people explore what the programming that we discussed, what the contexts are. So high schoolers, and I really advise that, enable the students to see how they are capable to use a new building of the code and how we can write the code. Actually, and I give the analogy as well, like we are in the digital native right now because most of the kids, most of the students are learning or exposing the digital environment day number one when they go to the schools. Like they can use the ecosystem such as mobile devices, they can use the tablet, they can use the laptop, they can use everything as a computer. So the high school, they should really give an opportunity how this system is working behind the scene. How can I make sure that the students are learning, basically collaborating with the Google Doc as an example, maybe writing a script on Excel file as the macro, maybe writing a basic script of get their job done. So like building the concept of how it is going to work, and I can really get the students be ready of understanding the reason behind it, understanding the cloud, understanding the operating systems, understanding the basic coding. And basically, like you can use the Python code as my son, he used it this year, writing a Python code and start to build up a specific example or the application for them, you can learn. So when we go into the higher level and the college level, we also think about how can I make sure that I'm building a software system eventually will be used in the bigger context. So in the college, we always teach about the algorithms, databases, and other components, which it is good to have it. We should have it. No question about it. We need to understand the fundamentals. We need to understand how things are going to work out, what the best algorithms are. How can I really use the better memory? How can I communicate in a short messaging system? So we can learn that the college level, but at the same time, we have to tie ourselves how it's going to use in the industry practice. We should connect ourselves more about experience, more about trying something. I always encourage the students, if you're in high school, try to build up something for yourself. Maybe you just can automate your document sending to your teacher. Like try to automate that if you can. Maybe you're writing a basic PowerPoint. Try to write a basic macro in your PowerPoint and try to automate some of the visualization and graphics in your PowerPoint, which is doable. So think about how can I look? It's going to tell you to start some knowledge of the scripting. So when you go to the high school, the college, now you're going to get how can I build up something that I can use and using my GitHub environment, open up a space in the GitHub, try to expose more realistic scenarios, more realistic example. So what we are learning, we can apply in the real world scenarios. I see a disconnect between, because even though my students, I saw sometimes they know the fundamentals, but it's not as realistic in the real world scenarios. How can we manage that? How can I manage the users? How can I manage some complexity? How can I manage basic writing code versus writing on desktop or sharing somebody else? It is more about experience. So I want them to think about out of box, think about how can they use different contexts, more realistic. When they go into the more realistic example, they will learn how to build up the software. They will learn how can I speed up the pipeline, which goes back to software factors. They will learn how can I reuse my code over and over again, because they're going to write the code. They will see the similar code again, and they will think about how can I make it a little bit modular of my code that I can reuse again in the futures. So this is basically going that direction. And then in low code, no code, that one of the part in the questions, it's more about the reusable of existing application for over and over again without writing so much code. And most of even though sometimes we use that, we're not writing the code, but using a shared code as an example. We're using other ready solutions as either drag and drop or connecting dots without writing much code, but just reconfiguring an application to serve our needs. That's going to help us. So most of the students are already using that directions.
Another great answer, Hasan. Thank you for that. We've got a good question in the chat from Rajiv asking, how does container technology change DevSecOps?
All right, that's another good question again. Love that discussion. So let's talk about what the container means, so we can maybe come back to DevSecOps a little bit. So let's go this way. Like DevSecOps is a set of practices and principles for us. We are building continuous integration, continuous delivery, continuous feedback, all this continuous term in the DevSecOps practice. So what the container is, as the little bit background, container is giving a process and isolated from operating system for serving a specific needs. So it's basically specific to the app content and isolated from others. I have an app one here, I may have an app to here, both are isolated each other's, I can do that. So going back to the continuous integration, as we said, we would like to automate a build as fast, as quick as possible. And also we would like to deploy without changing much in the production environment. So automation and deployment are the key element is helping us make it a containerized applications. If my application is more container, more isolated others in a small size of the Docker file or the specific features, then I can automate the build and I can deploy without affecting others. So in this context, is really helping to speed up delivery, speed up testing, speed up automation. Because I can stand up at different test harnesses for this container separate, this container separate. I can run 2 of them in the same environment. None of them is going to be interacting each other as they're using different, maybe using a different libraries, different versions, same libraries. It's going to help us to deploy quickly. So how can we use this container? I think we should discuss a little bit more as well. It's about architecture element. As we said at the beginning, so you may be creating a one service as an application one. It may be one of the microservice that you may be writing here. So because you are getting more specific to the service and how application one or app one is communicating with others. Same thing for A2 and communicate others. So you may be writing a microservices. So microservices is the way of architecting. You are packaging your services in the container so you can push into your pipeline. So like pipeline is we established, now we are adding an architecture components of the system that we are building and packaging as a container and calling as a services. That's the relationship. I can deploy it. Maybe one of the messaging services that I may have, maybe some of them are payment related, some of them are report, and some of them has possible maybe sending some message to other components. Some of them is just a database communication. So it depends on the service type. And we are packaging the service and put in the container and then ship into the production or deliver into the staging environment. So it is helping the DevSecOps go much faster by using continuous integration, continuous practices. If we don't have a container, yes, we can do the same DevSecOps practices, but we have the right test automation. We have the right deployment packages. Maybe we have the right different build packages. Maybe have a multiple pipeline, we set it up. So in that connectivity, it is helping to go much faster in the context. But it is important to make sure that we are writing the right container files to meet our needs. But we don't want to creating a container file that's about the 1 gigabyte size. It's not going to help. So make sure that you are following the best practices, how to make sure that we have a right layer architecture in the containers. How can we write a very minimal size of the containers we can go fast in the DevSecOps deployment and test cases. So we can enable the reusable of the components in the libraries that we have the layers of the container we can use that. It is really important to make sure that we have a right container architecture that we are following and we can use over and over again. Because otherwise, put everything in one container, make it a 5 gigabyte size, it is not going to serve the needs of the DevOps perspective. It will be late to deploy. It's going to be problematic to deploy into the production environment.
All right, switching gears, Kim sent in, can you explain the DoD Enterprise DevSecOps Initiative, or DSOP?
Right, so I'm glad that Hasan Yasar, this is a great group. I'm part of that DevSecOps working group as well. So in the DoD, we see many different type of implementation in terms of DevSecOps practices and in terms of the different understanding. As this subgroup is really helping the common understanding of what the DevSecOps culture should be in the DoD context, like maybe describing the playbooks, describing the framework, describing the vocabularies, describing acquisition perspective, and it is giving a guidance to the rest of the DoD, follow it. Remember that the software factory concept we discussed, we are looking for the same practice, the same process, a different implementation. This is exactly DoD DevSecOps working group we would like to do, which is doing it already. There's already, we can post the URL into the YouTube channel and people can download the latest version of DevSecOps framework and playbook and some other guidance that come from the US CSO Air Force as well. It's going to help us to understand what the commonalities of building up a continuous improvement, what the key capabilities are. We're looking forward to what the DevSecOps pipeline means, what the continuous integration means, what the continuous authorization means. So it's going to describe the vocabularies and describe the common understanding, and also giving some reference architecture. Let's say you would like to use the Kubernetes and Docker, here's reference architecture for you as an organization. You can follow that reference architecture, build up your own Kubernetes container-based DevSecOps environment. And then another things also it's important to mention here, Shane, and a little bit about the container as well. It's also offering hardened containers, so rest of the DoD folks can use the hardened containers. What really means, and in DoD context, we always would like to have an approval for the software. Without having an approval, none of the software and system will go into the production environment. It is requiring authority to operate, which is AO, and then we are adding a continuous ATO. So continuous ATO, authorized to operate, is continuously requiring a constant evaluation, constant check of the libraries, dependencies, application with respect to security. What the DoD DevSecOps initiatives is really building as hardened containers. The hardened containers has already approved dependencies libraries for one of the modules that developer might be using it. That module can be a Node.js, can be one of the pipeline component, can be a GitLab, can be a Jenkins, maybe data science using some Jupyter, some other tools, has approved already in the available public platform. And then people in DoD users, they can pull that libraries from the common portals and use in their application context. We can cut the reapproval process in our approval components. So we can use the approved containers to speed up our approval process so we can go faster. So that's another thing as the DoD DevSecOps initiatives is helping. There are many other activities as well as part of this group. And there is embedded software development group is happening right now. We haven't really publicized yet every output, so still is building up. How can I use the embedded software development DevSecOps context? And there's another studies happening as part of DevSecOps group. It's about digital engineering. And there's another connectivity between digital engineering and DevSecOps. I think there's a webinar we did a couple of months ago. And there is a direct connectivity. How we're setting up our digital engineering ecosystems on a software pipeline, which is DevSecOps pipeline. We can go back and use in the digital engineering concept using a source of truth. Other component will be part of it. So it is giving a good guidance and DoD. At the same time, a lot of industry folks also using that. How can I use a typical DevSecOps framework in a highly regulated environments, like the health industry or the finance industry are good examples of consumers of the DoD built DevSecOps framework.
All right, we're down to about 7 minutes, Hasan, so we're going to just rapid fire as many through as we can here. Some, if some are too long, Hasan, we can pass, but we'll just try to get through as many as we can here. M had asked, does the size of an organization have any effect on DevOps implementation? What he means are big organizations better suited to implement DevOps, or does size not matter? So
I will answer it in a different way. Size matters, but actually depends on organization culture. If you are, let's put it this way, if you are starting from a greenfield application, pretty much easier to implement DevSecOps practices in the organization or the system that we are building, because everything exists from scratch. If you are going into the brownfield application, let's say you have a legacy system, you may have a component has been done already, to convert into the DevSecOps, it will take time. So DevOps is applicable for everyone, first of all. How are we using the DevOps in our business context? It depends. It goes back to our continuous delivery deployment discussion. As the good organ, it doesn't matter which organization you are in, make sure that, maybe I should use the drawing probably much better, quicker way to explain that. I always suggest that no matter what organization you are in, keep your repository management in your organization. Single repository management. You may have a different team 1, team 2, team 3, team 4. So everybody's going to use the same repositories as the source of truth as the repositories. Then you can build up a set of principles and practices this team can use. They can build up their own DevSecOps environment for their needs, for their application. They can build up. Suddenly, this organization is becoming a software factory. It's becoming they're setting up their environment. So it is good, everyone, but implementation is really changing. And think about if you have a team with the 10 people, your communication will be only limited to the 10 people. If you are thinking about the bigger scale and suddenly you need to communicate each of the members has to communicate each other. You know that you don't need to collaborate everybody in an organization, but you can build up a common understanding of each of these teams, how they would like to do DevOps implementation, let them share information in between and go into the team level, let them do what they would like to do for implementation of DevOps or DevSecOps they're implementing. So organizations, if you have a good policies, they can use it. It's more about how I'm going to change myself in an organization or a small team to do my job in a DevOps way. Like, it's more about again, it goes back to the cultural element, the collaboration pieces. No matter where you are in, ask yourself, you're a developer, you're a program manager, maybe an architect, maybe a tester. How can I change my job to serve the DevOps needs? What the DevOps needs are, as we discussed at the beginning, we need to collaborate that. How can I collaborate with the rest of team members? Think about what is next, where I'm getting this information, or how I'm going to share with others. If I'm writing a code, what other team members that I need to expose my information? How can I share my lesson notes? So it's kind of like a changing of how we are doing it and then scaling up. So we can scale up by doing the same thing and scaling up other team members so we can build up organizational knowledge. So differences will be in the brownfield versus greenfield, but the size, it will take time if you're a bigger organization, take the DevOps implementation in a bigger organization. But a small organization, probably much quicker, much faster because small team members are part of it. You can focus on your business, you can focus on your environment much quicker than others. I'm trying to give a short answer, but another long talk that we can discuss.
That sounds good. William asked, can you use DevOps for machine learning? I've seen the term MLOps. Are there similarities? Can I use my DevOps pipeline for machine learning development?
Yes. 3 times yes. Yes, we have to use it because if you look at the typical deployment rate, now it's happening, the AI engineering development deployment, there's a disconnect. It's happening. How can I get the package of the model and put into the deployment pipeline? So just pause it here. Let's see if you look at DevOps specifically, DevOps is really helping to deploy any capabilities. What the ML component is bringing up a data element. It's bringing another modules in the context. So application that we are building DevOps environment, actually it has the part of the model as part of application. You can package an application as the model behind the scene and you can deploy. So the concept of MLOps actually extending the model deployment, model creation, model curation, model deployment into the pipeline using DevOps pipeline, basically. So basically getting the model into the DevOps pipeline, use the continuous integration example, use the continuous deployment delivery practice example, use the continuous feedback example, feeding back to the data scientist how the model is behaving in application context. So why MLOps term got grow actually came from the Google a couple of years ago. And they realized that without using their best practices in terms of delivery and deployment, it is hard to make the reality of the model in the real environment. And there are a lot of scenarios happening at the past. There's a Microsoft PyBot happened a couple of years ago. If you don't have a good mechanisms of monitoring how the model is behaving in production environment, and you can act proactively, see models behaving, it's gonna get done through the DevOps concept as the monitoring at the beginning. So I will say MLOps is adding an ML component, data component into your DevOps pipeline. Make sure DevOps pipeline is supporting not just the code, and also supporting other elements such as data, such as feedback, such as model monitoring in your DevOps pipeline. So maybe say that like an extended version of the DevOps thing with including the MLOps concept in it.
So Hasan, we got about a minute left here. So if we can limit this to a minute, if possible, from Kartik, the last one we're going to ask is, can you please describe the POD-based delivery model and distinguish it from the factory model? Is that a quick answer?
It's going to take longer. It will take more than a couple minutes to answer that. Okay. I will respond to that questions probably in email.
Okay.
Or the chat.
That sounds terrific. It just gives us a reason to do more of these, because there's lots of questions we didn't get to, Hasan. But just a great session. Thank you so much for taking the time to do this. You are one of the reasons why the SCI is so valuable.
Thank you so much, Shane. Happy to discuss with you. We can repeat this section and get more questions. I know there should be more questions we haven't touched up yet.
No doubt about it. So thank you again for sharing your expertise. Folks, we want to thank you all for attending today, for sending in such great questions. Like I said, just continue to send those questions in. We will try to set up another one of these sessions. Upon exiting, please hit the like button below and share the archive if you found value today. Also, you can subscribe to the SEI YouTube channel by clicking on the SEI seal in the lower right corner of the video window. Any questions from today's event? Please send to info@sei.cmu.edu. Thanks, everyone. Have a great day.